Okay, student, see the question number 27. Okay, question number 27 is about, for the given figure, the switch A network is given here. A network is given. So that is my network here. So this is 20 volt, 40 volt. This is my 20 volt, 20 volt. This is 20 volt. Okay, and this is my positive, negative 20 volt. Yes, and here you see this positive, negative, and this is about 40 volt. Yes, this is 40 volt, positive, negative. Now you see here switch is given. This is my switch. Okay, so switch is connected to position 1. This is my position 2. Okay, so now, and this is connecting to what? This is connecting to resistor and capacitor. Resistor and capacitor. Okay, so let us resistor, capacitor. This is given. Yes. So now this is 500 ohm and capacitor is 0.5 microfarad. 0.5 microfarad. This is current I. Okay. So now this is my switch K. K. Switch K is connected to position 1 at time t is equal to 0. At time t is equal to 0, the switch K is connected. Now he is asking what at time t equal to 0. Okay, after t is equal to 1 t second, one time constant, the switch is moved to position 2 after one time constant. Okay, after one time constant at t is equal to 1 tc. At 1 tc means switch is connected to what? Connected to what? Position number 2. Okay, this switch is connected to position number 2. Position 2 at t is equal to 1 tc, one time constant. Now he is asking that just find the current I at 1 tc negative just before one time constant and 1 tc just after one time constant. Okay, find the current. That is what? Current. Current at 1 tc, 1 tc negative just before one time constant, and current at 1 tc, current at 1 tc positive just after one time constant. Okay, so this is the question about this circuit. So first of all we will start what? First of all, see, this is network. Okay, now this is at time t is equal to 0. At time t is equal to 0, t is equal to 0, switch is connected to, this switch is connected to position 1. Okay, position 1. So before t is equal to 0, where is the switch? Where is the switch before t is equal to 0? Before t is equal to 0, this switch is obviously is disconnected to both of these battery. Okay, both of these battery. Then in that case, where you will see before t is equal to 0, case first. Okay, so when you will see case first, just when you see case first. Okay, first case. When first case, what? When t is less than 0. When t is less than 0 means switch is open. Yes, switch k, switch k is open, is disconnected. Yes, switch k is disconnected. Switch k is disconnected to both, disconnected to both. Okay, both 20 volt battery, both battery. Okay, both battery of 20 volt and 40 volt. Yes, now here if you see, the circuit is like, this is switch, this is an open mode. Okay, so it is, this switch is directly connected to this resistor, capacitor. Okay, resistor, capacitor, and here it is disconnected. Okay, so this is what? Switch. This is my switch. Okay, it is not connected to both of the battery. Okay, so this is what? Positive, negative, positive, negative. Here positive, negative, positive, negative. This is my 40 volt battery, this is my 20 volt battery. both are disconnected. Both are disconnected. Okay. So when both are disconnected, then both are disconnected. This is for t less than 0. Yes, this is 500 ohm. This is what capacitor 0.5 microfarad. Yes. Now see. Now see, when time t is equal to time t less than 0, before t is equal to 0, the circuit condition is like this. Now see here, this is like open circuit. Yes, this is RC that is connected in series. Okay, and it's open circuited. Yes, for a very large time. If we see for very large time, this circuit will go to in what? This circuit will go in steady state. For very large time in negative. Very large time in negative means t approaches to minus infinite. When t approaches to minus infinite, this capacitor will get open circuited. Yes, capacitor will get open circuited. So this is nothing but like this. This is resistor and this capacitor will get open circuited. Okay. So this is what VC of 0, VC of what? VC of 0 negative. Yes, this is positive, this is negative. 500 ohm. Yes, this is switch K. Nothing is not, no current is there, means current is 0 ampere, 0 ampere, and this VC 0 negative is nothing but 0 volt. Yes, this is what? 0 volt. So now see here, VC of 0 negative is equal to what? 0 volt. Okay, so now this is what? First equation number 1. Now let us say, because in steady state capacitor will behave like a open circuit. Okay, open circuit, and this VC 0 negative is equal to 0 volt. Now coming to when switch A is connected to battery of 20 volt, then in that case, see here, then number 2, if you see when switch, okay, switch K is connected to when switch when switch K is connected, when switch K is connected, when switch K is connected to 20 volt battery, 20 volt battery, 20 volt battery, then in that case, if you see when the switch K is connected to 20 volt of battery, so then the circuit will look like this is my positive negative, positive negative. Okay, so this is my resistor and this is capacitor, capacitor. Okay, and this is 0.5 microfarad and this is my 500 ohm and this is my battery of 20 volt, 20 volt. Now see here, now see in this case, okay, now this is at time t is equal to 0, okay, at time t is equal to 0. Now this is 20 volt. Initially if you see the capacitor, capacitor is initially not charged. Okay, so capacitor initially it is not charged, charge across the capacitor is initially 0, because if you see here from here VC of 0 is equal to 0 means initially the circuit is not, circuit is relaxed, circuit is in relaxed mode initially. Okay, so there is no charge across the capacitor because VC of 0 is equal to 0 volt. Q is equal to CV. CV means V is 0, means Q is 0, means initially this circuit is what? Relaxed mode. Okay, relaxed mode means initial condition is 0. So now see here, this through this 20 volt battery, now this capacitor will start charging. Yes, now this through 20 volt battery, this capacitor will start charging. Okay, now see here, this capacitor will start charging. If we see here VC of 0, VC of 0 initially. Okay, for time t less than 0, we have seen this VC of 0. Now as it is charging through this 20 volt battery, okay, once 20 volt battery, then it will finally it will reaches, okay, when it will fully charge to 20 volt, when it will reach at what? When it will reach to steady state. Okay, once the capacitor reach to steady state, once the circuit reach to steady state, then this capacitor will get fully charged, through this 20 volt battery. Okay, through this 20 volt battery. So initially charge across capacitor is 0, so therefore voltage across the capacitor initially is 0. Now as we increase, as time increases, okay, as we increase, as this capacitor is starts charging, okay, charging toward its steady state. At steady state it will steady state when it will reach to steady state at Vc of infinity, okay. At Vc of infinity, if you see this capacitor will get open circuited, because this circuit will reach at once the circuit will reach at steady state, capacitor will get open circuited, okay. Once it will get open circuited means this what this whole of the voltage will come across this capacitor, okay. How much is this voltage? 20 volt. Yes, this voltage is 20 volt, okay. So this voltage is 20 volt, and this initial voltage that we have found is Vc of 0 is equal to what? 0 volt. Yes, now see here time constant is what? For t for t greater than 0, time constant is nothing but tau is equal to RC. RC is what? If you see, R is nothing but 500 into capacitance. Capacitance is nothing but 0.5 microfarad. Yes, now if you see here time constant is nothing but 5 by 5. How much is this? 1 by 2. 5 by 2. 2.5 by 2. Yes, so this is nothing but 2.5 into 100. This is 250 microsecond. Yes, this is 250 microsecond. Time constant. Okay, so this is my time constant. Now see, if we see that equation voltage equation for capacitor is nothing but Vc of t is equal to what? Vc of infinity plus Vc of 0, okay, 0 positive minus Vc of infinity into e to the power minus t by tau, okay. So this is what Vc of, if you see Vc of t is equal to what? Vc of infinity is what? How much? 20 plus Vc of 0 is 0. Yes, because Vc of 0 negative is nothing but Vc of 0 positive, because as we know very well, the capacitor does not allow the sudden change of voltage across it. So therefore Vc of 0 and Vc of 0 negative and positive both are equal. And Vc of infinity is how much? 20 e to the power minus t by tau. Tau is 250 microsecond. Yes, 250 microsecond means here it is 10 to the power 6 by 250. Once you will solve, we will get Vc of t is equal to how much? 20 into 1 minus e to the power minus. This is what, if we solve this is something like 10 to the power 6 divided by 250. Yes, 1010 will get cancelled, and this is nothing but 100 into 1000. This is 4000. Yes, so this is 4000 t. Yes, so this is nothing but 4000 t. Yes, it is 4000 t. 1 2 3 4 5 6. Yes, 250 microsecond. Yes, 4000 t. Now this is our charging equation. Yes, of what? Capacitor. See here, capacitor is actually charging toward 20 volt. Yes, at steady state it will charge, it will get fully charged with 20 volt in steady state. Yes, in steady state. So this is what charging equation of this capacitor, okay. If charging equation of this capacitor, okay. So now we will see what Vc of what? Vc of t. We will see this voltage across capacitor at what? At one time constant, okay, at time constant tau. We will check this, okay. So we will solve this voltage. Now let us see, let us remove this now, okay. So which we can remove, so let us remove this from here. Now if you see here Vc of t, let us see at t is equal to 1 tc, at t is equal to 1 tc. Yes, means one time constant, okay. So which means what? Which is nothing but t is equal to 1, t is equal to tau, okay. T is equal to tau means what is Vc? Vc of tau is nothing but, if you see Vc of tau, is what? This is nothing but 20 into 1 minus e to the power minus t by tau, means what? This is nothing but 20 into 1 minus e to the power minus tau by tau. What? Tau by tau. This is nothing but 20. 1 minus e to the power minus 1. So how much is this? 20 into 1 minus e to the power minus 1. Yes. So if you see this Vc of tau, yes, how much we will get? This Vc of tau is nothing but, if you see 20 into 1 minus e to the power minus 1, how much it will come? So this is nothing but 20 into 1 minus E inverse is nothing but 0.3678. Okay, so once you will solve this, we will get 12.64 volt. Yes, so which is nothing but Vc of tau. Vc of tau. Okay, so now this is our voltage across capacitor at time constant tau. Okay, so now we will calculate what? Current. What? Current. Now see, current. Okay, so current before what? Current at 1 tau, what? Tau negative. Okay, one time constant negative. Constant negative means just before time constant. Just before time constant. Just before time constant means this that circuit is connected to what? 20 volt. Connected to 20 volt. That time the current is what? Current is nothing but I is equal to what? 20. I is equal to 20 minus, okay, minus Vc of what? Vc of tau divided by how much voltage is there? So Vc of tau voltage is that resistance is 500 ohm. Okay, so Ic of tau, this is what? Current at tau negative means it is just before one time constant, ampere. Okay, so this is nothing but 20 minus Vc of tau is nothing but 12.64 divided by 500 ampere. Yes, which we will get 1 tau negative is equal to 0.01478, something like this. Okay, so somewhere around, it is somewhere around 0.0148. Yes, so this is nothing but IC, this is nothing but I tau negative is almost equal to 0.0148 ampere, 8 ampere. Okay, so this is what? 1 tau negative means just before one time constant, the current. Okay, current through what? Current through capacitor is this much. Now we will see current through capacitor. We will see current through capacitor just after one time constant. Just after one time constant. If you see, just after one time constant, the switch K will connect to what? The switch K will connect to 40 volt battery. Yes, 40 volt battery. So that is nothing but current. If you see current at 1 tau positive means it is one time constant. Just after one time constant, the current through the capacitor is nothing but, if you see now, this switch K will connect to 40 volt battery. 40 volt battery. Okay, so and it is resistance and this is capacitance. Okay, so this is my 0.5 microfarad and this is my 500 ohm and this is positive negative and this is 40 volt battery. Yes, now this current at tau positive. Okay, just after what? Just after one time constant. So I tau positive and here capacitor voltage across the capacitor Vc of tau. Vc of tau. Okay, just after is same. Okay, because if you see here Vc of what? Vc of tau is equal to, Vc of tau is nothing but Vc of tau negative is equal to Vc of tau, Vc of tau positive. Okay, Vc of tau positive, because this is what? Sudden change. If you see the voltage across the capacitor, there is a sudden change in the voltage across capacitor. So therefore this will be same, because the capacitor does not allow the sudden change of voltage across it. So therefore whatever voltage we got here at time constant tau, same voltage will appear at time t is equal to 0 t at time what? At time tau positive and tau negative, because these are sudden change of voltage across the capacitor and capacitor does not allow the sudden change of voltage across it. So therefore this will be same. Whatever voltage we got here at tau, okay, the same voltage will appear across the capacitor, okay, across capacitor we see for tau negative and tau positive, okay. So that's why, that is the reason, that because capacitor does not allow the sudden change of voltage across it, okay. So therefore VC of tau negative is equal to tau positive is similar to VC of tau. So therefore I tau positive is nothing but nothing but 40 minus VC of tau. What? VC of tau positive divided by 500 ampere. Okay. So which is nothing but, if we see here, 40 minus 12.64 divided by 500 what ampere. Now see here IC. I tau positive is nothing but equal to 40 minus 12.64 is what? 40 minus 12. 40 minus 12 is how much? 40 minus 12, if you see, 28. 28 means it is 27.36 divided by 500 ampere, which is nothing but around 0.055. Okay, so this is I of tau positive is almost equal to 0.055 ampere. Okay, 0.055 ampere of current. Yes, so this we got I tau negative, I tau positive. So therefore option A is correct. Option A is correct. Okay, so therefore option A is correct for question number 27. Okay, 27. That we have seen, everything we have seen. Okay, line by line, because he is asking the current just before time constant, just after time constant. Okay, so therefore the voltage across the capacitor will appear similar to what? Similar to VC of tau, because these both voltage at tau negative and tau positive is what? These are sudden change of voltage. Therefore these both voltage are equal to VC of tau, because it does not allow the sudden change of voltage. So therefore these are similar to VC of tau, whatever voltage we got here. Okay, VC of tau. That's all about this question number 27. Just move on question number 28.